Okay, welcome to part 2. We got the movement of A and B. We're going to focus on C and D and then the absolute values on this video. Hopefully we can get through. So we're just going to flip right on over to C. And so our C, if we look back, our C is going to be moving right or left. So we are going to move right if we have a negative C. We're going to move left if we have a positive C. And so in this one, we're going to do y is equal to f of x plus 2. So we ask ourselves, okay, x does just the opposite of what we're thinking it's doing. So instead of going to the right like it would normally do, like y does, it was going to go to the left. So this is going to be left 2. Left 2. So what we have here is we're going to take our parent and we're going to move all our values left 2. So we have negative 4, 1. Then we have negative 3, 0. Then we have negative 2, negative 1. Then we have 0, negative 1. And we have 1, 0. And then we're going to connect our lines, our line segments. And then we have the movement that we moved this parent left 2. Okay, let's take a look where D is. D's on the outside. And so that's like our K. So we're going to go and do what's true. This is a vertical movement. This is the Y that's being affected. So we're going to move or translate our vertical shift. Up would be the best. So we're going to move up with a positive D, and we're going to move down with a negative D. Y's behave just like we want them to. So in this one, we're going to do y is equal to f of x minus 2. So if you're struggling with really what that is, this tells me I'm going to take y and I'm going to subtract 2 from it. It does exactly what you tell it to do. So let's get our parent back in here. We're going to move our parent. And so we're going to do exactly what we said. Okay, so the first one, we're going to be at negative 2, negative 1. The second one, we're going to be at negative 1, negative 2. Then the third one, we're going to take 0 to negative 3. Then we have 2, negative 3. And then we have 3, negative 2. So all you can see is that we took our parent and we moved it down. We had a vertical translation down 2 units. So that's what the D controlled. Okay, let's change to the absolute value. So in the absolute value, all parts of the graph in quadrant 3 or 4 reflect over the x-axis. So I'm going to take a second and write that down. So if we think about some geometry in here, we take our xy and we're going to transform it to x negative y, or x the opposite of y. So what we're doing here is we're taking in quadrant 3 and 4 is anything down in the lower two quadrants where y is negative, and this is telling us we're going to take, sorry about that, this is telling us we're going to take the absolute value of y. So when I take the absolute value of y, it's got to be positive, and so we're just reflecting that piece over. So we're going to get negative 2, 1. Okay, I'll get our parent back in here, and then we're going to go to negative 1, 0. Those points are going to stay the same. But this next point, 0, negative 1, is going to go up to 0, positive 1. And then 2, negative 1 is going to go to 2, 1. So we're reflecting that y piece over. And then we still have 3, 0. And so our parent changed, we changed the look of the parent just a little bit. Almost looks like a inchworm or a turtle going around on our axis, but that's what we've got. Okay, so for our last one, when we take this one, what we're doing is the parts of the graph in quadrant 1 and 4. So we're talking about 1 and 4 over here. So we have 1, and we can have 2, 3, and 4. Probably wouldn't hurt to go back and put that in the other one too. So we have 1, 2, 3, and 4. So the right side of our graph is going to reflect over the y-axis. The parts of the original that are in quadrant 2 and 3, where our x's are negative, are going to be removed. So if we think about our parent, this little hunk right here, this little strip right here is going to be removed. So we're sitting there with this, and we're going to reflect that over the y-axis. So let's go ahead and graph this, and then we'll get it written down. Okay, so what we have is we'll have 3, 0. I'm going to kind of work backwards on this. 3, 0, and then we'll have 2, negative 1, 0, negative 1. And these are fine because all the x's are positive. And so now we're going to reflect these over. So we have negative 2, negative 1. And then we have negative 3, 0. And we end up with our parent. That shouldn't look like that. It's got a gap in it. But we look at our parent and we see that it is reflected over in our quadrants. So remember that what we just did is the parts of the graph in quadrant 1 or 4 are reflected over the y-axis. The parts of the original in quadrant 2 and 3 are removed. And we did remove, if you'll look at the parent next to this, we did remove this little piece right there. And so that is our transformation flip chart that gives us all of the movements. And the reason why we want to do this, we want to look at any function and say, okay, you're going to do this, you're going to do this, you're going to do this. And let's put that into a real quick example of what we're doing. So if we take our parent quadratic, and I'm just going to sketch this. We have 0, 0, we have 1, 1, we have negative 1, 1, we have 2, 4, and we have negative 2, 4. There's our points that we have. So let's just say we have f of x equals, and I'm just going to put that for my y, equals negative 2x plus 3 minus 2. So this thing is going to reflect with this negative right here. This is going to reflect. This is going to cause a vertical stretch. We're going left 3, down 2. And we're all doing that from the vertex. So we're going to go 1, 2, 3, 1, 2. We're going to reflect. So this thing's going to open down. It's going to get more narrow. And this is the reason why we want to do this, is to be able to graph these very quickly with all the movements. I hope you learned how to do all the movements, and you will use this foldable as you work on your Moving the Monster project, and as you finish up your transformations, and as we work through the rest of our parent functions this year. Hope you have a wonderful day.